So, before going to the actual presentation of taking advantage of the multi-master Galera cluster, let me just explain Codership with a few words. We are established 2007, so we have been developing Galera cluster already for 10 years now, and it was founded by three co-founders who did three other MySQL replication clustering solutions. So they had a pretty good understanding what was wrong, especially with the master-slave replication, what were the drawbacks, and they got this idea how to improve this replication with Galera cluster and features with the Galera cluster. Galera cluster is based on the academic research, and we are all the time following the academic research when it comes to the distributed computing architecture and designs. And our product is Galera Cluster. It's open source. What we sell is support and consulting, mainly through our partners like MariaDB. And since 2009, when we launched the GA product of Galera Cluster, we have had 1 million downloads, over 1 million downloads. And there are thousands of users in e-commerce, telecom, gaming, media, healthcare, lottery, etc. Galera Cluster is included in some of the Linux distros, and it will be coming up to some more Linux distros next year. Galera is also recommended by all the big OpenStack vendors like Red Hat, Mirantis, Rackspace, Dell, Ubuntu. They are using Galera Cluster as a default solution for the high availability. And the latest survey showed that 34% of the OpenStack users are using Galera Cluster for the OpenStack high availability. Typically, customers are using Galera Cluster for high availability. They cannot tolerate downtime. They cannot tolerate loss of transactions or data or money. But they are also using it for scaling and disaster recovery purposes in cloud or in wide area network. There are three Galera Cluster versions in the marketplace. First of all, there is Galera Cluster from Codership, Galera Cluster for MySQL. Then there is a MariaDB Galera Cluster or MariaDB Enterprise Cluster, and then there is Percona Extra DB Cluster. They are all based on our Galera Cluster replication blocking. And out of these two, MariaDB is our preferred recommended partner. We work closely with them on bug fixing, new features, roadmaps, and so on. But with that, I would like to give the microphone to Philip Stoev, who will do the actual presentation of the webinar.
Hello everyone, my name is Philip Stoev and I will be presenting the webinar today. The topic is taking full advantage of Galera Multi-Master. So our agenda for today is I'm going to do a very quick overview of Galera Cluster. Then we're going to cover some general principles that apply to running multi-master workloads in Galera. Then we're going to talk about actual application features that would be nice to have for multi-master and the different workloads that are well suited for multi-master deployments. And finally, we'll talk about some configuration options in Galera that are useful, how to monitor the performance of multi-master, and how to troubleshoot certain situations that may arise. So first of all, a very quick overview of Galera Cluster. It is a synchronous multi-master replication solution for MySQL. Synchronous meaning that each transaction is immediately replicated on all the nodes at commit time, which does not give opportunity for slaves to lag very much behind the master. So all the nodes in the cluster are kept synchronized. It is multi-master, as we will see later, meaning you can read and write from any node. It is based on replication, so it is not a sharding solution, but instead a copy of the entire data set is available on all the nodes. But Galera internally allows you to add more nodes to the cluster, and it will make sure that the nodes can join and get a fresh copy of the database. This all happens automatically. And finally, it is based on MySQL. So we have modified versions of MySQL 5.5, 5.6, and 5.7 is coming up. And the underlying storage engine is still InnoDB, which means that all the usual performance enhancements, optimizations, and all the other tricks that you may know about InnoDB apply equally to Galera. Furthermore, Galera cluster recovers from node failures within seconds. There is no complicated failover procedure or to elect a new leader and things like that. All of this is handled internally. Very quickly, an outage is detected and the cluster continues to run. And also the product offers very strong data consistency protections. The integrity of the data is the paramount design consideration for Galera. So you're prevented from both making your data inconsistent and from reading stale data in your cluster. And finally, the product has very good support for cloud environments, and you can also have a cluster that operates over a wide area network. You can have a cluster where the nodes are in different geographical regions, different countries, or even different continents. So with that said, I'm going to say a few words about multi-master and what it's all about. So as you probably know, multi-master is the feature where you are allowed to issue any transaction on any Galera node. There is no need to have a master node and for writes and use other nodes only for reading. It is possible to issue any read or write transaction to any node. And this ability is a core design feature of the product. It is not something that just happens to work. It is something that the product was designed to accomplish from the start. Also, it is something that happens out of the box. There is no need to specifically enable it or configure it, even though, as we will see later, there are some configuration options that are useful. What are the benefits to actually having a multi-master setup and allowing your application to write to any database node? First and foremost, it is to get additional operational flexibility. If your application is able to take advantage of multi-master, this means that there is no need to designate a single node and use it exclusively for writes, which in turn can simplify your load balancer configuration, and in general, you no longer need to distinguish between different roles for the nodes in your cluster. So if you need to take a node down, it does not matter if this node was the node that you are habitually writing to, since you can write to any other node as well. And if you need to have some downtime, or if you have a node failure, it doesn't matter which node is affected. And furthermore, for wide area networks, it is very good for performance that applications can read and write from a node that is closest to them geographically. So multi-master gives you that in those geo-distributed clusters. A few words on the general principles and the way Galera operates in multi-master mode. As I mentioned, Galera places data consistency as the topmost priority, meaning that conflicting transactions that were issued on different nodes will be detected, and the transaction that committed first will succeed, and those that attempt to commit after it will get a deadlock error. This is slightly different from the single master case where any conflicting transaction will wait. In Galera, it will get a deadlock error immediately, so there is no waiting involved. And furthermore, if Galera detects that a particular transaction has no chance of succeeding, it can be aborted even halfway through. A deadlock error can happen in the middle of the transaction if Galera detects that this transaction is not safe to continue. And there is this rule that we call Callahan's law, which is that a given row in your database cannot be modified more than once per the round trip time of the cluster. So if you have a distributed cluster with nodes on the east coast and the west coast of the United States, let's say that the round trip time is 50 milliseconds between the two, you cannot update a given row from those nodes more than once per this 50 millisecond period. This is a requirement so that the consistency of the data can always be ensured. This is due to this replication delay, which is a function of the speed of light. But this applies only to updates that hit one and the same row in the database. If you're updating different rows, then you're not bound by this restriction. If your cluster is only contained within a single data center, within a single rack, obviously the round trip time will be very low, and therefore you will be able to issue many more updates per second, even against the same row over and over again. If more updates are being issued than the network can handle, you will get more deadlock errors. A question people ask is whether multi-master will give you write scaling, meaning if you have 5 or 7 nodes in your cluster, does it mean that you can issue 5 or 7 times more write queries to the cluster than you would from a single node? And the answer depends on the nature of your workload. The rule here is that each node in a Galera cluster needs to perform all the updates made from every write transaction. But each node only makes the actual updates. So all the other activity that happens during the transaction, all the select statements that the transaction may contain, all the parsing, all the optimization, all the index loop, not the index lookups, but all the joins, all the full table scans, none of this effort will be duplicated on all the nodes. So it is possible to get some write scaling out of this, and we will discuss later about which workloads are more amenable to being scaled that way. So what is important to have in mind is that some work will get duplicated on all the nodes for every transaction, but not all the work that happens in that transaction. So the next topic is to discuss how the application should ideally behave if you want to run it in a multi-master cluster, and what types of workloads are suitable. But the rules that we are going to show, or the principles that we are going to show, are not absolute, meaning that we encourage you to try your application with multi-master, to try your workload and see if it works for you. and this is the way to know if it's a suitable one. So first, a few words on the actual application design. Again, those are more suggestions. So first of all, you should know whether your application uses fully formed transactions or individual auto-commit queries. This is important because certain optimizations, certain situations apply only to one or the other. Some applications do not use transactions at all. So each query is run on its own, but other applications have through transactions with the start transaction statement followed by some work and finally a commit or a rollback. So when it comes to designing the application or retrofitting an existing application, it is important that the application can handle a deadlock error both during the actual transaction and at commit time. When an application is running against a single master, very frequently it will not see any deadlock errors because InnoDB in this case may elect to wait instead of aborting a transaction. So when such an application is moved to a multi-master setup, it will start getting deadlock errors for queries that previously ran without issues. And sometimes it will be just any query from a transaction that was in conflict. So a deadlock error can happen even on a select statement that is not updating anything, as long as it is a part of a transaction that updated some rows and caused some conflicts that way. So ideally, the application will be able to handle such errors, and the preferred way to handle such an error is to retry the entire failed transaction. If some transactions must absolutely positively operate on the freshest data possible, then ideally you should know what those transactions are within the application, so that there is a separate option that we'll show later that can benefit those. And finally, if you're really updating one and the same records over and over again from multiple nodes, then you may benefit from directing all the writes to those records to a single node, as we'll see later. So ideally, your application should be able to direct such writes to a different database node if needed. Regardless of whether you are actually able to change the way the application was written, even if you don't have control over the design of the application, even if you cannot make the application handle those errors or retry the transaction, one thing that you can hopefully certainly do is actually install better logging within the transaction, within the application. So make sure that all the database errors from the application are logged, and we'll talk about this later, so that those errors can be analyzed, and with the help of Galera, you can figure out why those conflicts happen. And if you have a truly legacy application that was never written with Galera in mind, that uses simple auto-commit statements, Galera will retry such statements if they fail for the first time, and we will discuss this option as well. Next topic, what are workloads that will work well in a multi-master setup? As mentioned before, update work needs to happen on all the nodes. So if you have a low percentage of effective database updates in terms of your entire transaction work, then you can actually achieve scalability, especially if those updates do not conflict with each other. So ideally, if your application is uses a lot of transactions that perform a lot of work, but only update a small set of rows. By making this application multi-master, you can take advantage of scale out. So here is an example of such a transaction, such a workload. A typical business transaction. So you start with start transaction, then you do a lot of selecting from different tables, you run some business logic, you make some business decisions within the transaction, and finally, as an outcome, you perform a limited set of updates against a table or a small set of tables. If your transactions are like that, then multi-master will give you even a performance benefit. Other transactions that are like that, those are not so realistic, but they can give you some idea of general patterns that you may find in your own application. So here is an example. We run a query against a very large table, but yet the result of the query is very small, so actual insertion into table T1 will be just a single row. For here, we have an update statement that is trying to find all the shipments where the sender country is Andorra and the receiving state is Wyoming. We see it will be the case that those are just a few rows from a very large table, because this particular combination is not likely to happen. So again, such an update, especially if the table is not fully indexed, will perform a lot of work to find those rows, but then only a few rows will actually be updated. On the other hand, here are some examples of workloads that are not so suitable for multi-master. One such example, if you're using your database as a NoSQL type of database, where all your updates are single row, without a lot of application logic behind them, without a lot of work being done within the transaction. In this case, you will not see a performance benefit from running those statements against multiple nodes. Also, some SQL constructs are not supported. For example, select for update, lock table, and get lock. Those only have effect within the node where they were run. So if your application has some logic that uses the get lock function to take a lock, you should know that if another part of the same application is running on another node, it will not see the locks that are taken that way. Another workload that will have issues in a multi-master setup are things that update hot rows in your database. So if you have a lot of updates against one and the same row in the database, Galera, in order to ensure consistency, will probably have to abort some percentage of the transactions that you're making. So if your application is using a database to store counters, to generate sequence numbers, or to it is used as a job queue or a walking scheme that has a lot of if those operations are done very frequently, many times per second, you will see that a lot of those may fail if you try to run them in a multi-master setup. And finally, if you have some long-running and housekeeping transactions, for example, if you have a nightly job that updates 1 million rows from your table, you may find that those transactions are not able to complete successfully in a multi-master setup, because Galera will abort them because they may conflict with the transaction that was issued by some other node. So in this case, it may be necessary to break down those long-running transactions to make sure into smaller segments to make sure that they will be able to complete successfully. Galera will handle auto-increment columns for you automatically, no matter if nodes are leaving or joining the cluster. So it is good to take advantage of this functionality within your application. If you are generating ID values for your records, it is not necessary to do this within the application. You can let Galera generate IDs for you. And finally, if you see a lot of deadlock errors, a lot of transaction conflicts because your application is constantly updating one and the same row, then ideally the application should be able to detect those updates to just a single node. But note that all the other updates that the application makes against other tables, against other rows that are not contented, against other schemas, can still be multi-master. So only the updates that are very contented, that suffer from a lot of contention, may need to be sent to a single node as a last resort measure. And there are even SQL level proxy servers that can read your queries and make an intelligent decision about the query and send it to a specific node. Or you can arrange for this within the application. And we will see later how to detect rows that are hot, rows that are frequently updated. Okay. Some words on how to configure Galera for multi-master. As mentioned previously, it works out of the box, so you can try it right away. But there are some options that are useful. One is this recept retry auto commit. This is the ability for Galera to automatically retry any auto commit transactions that failed due to a conflict the first time. Then we have recept sync wait, which you can use to ensure that the transaction operates on the freshest data available. And finally, we have recept log conflicts, which prints additional information in the error log, and we will see that later in this presentation. So first, retrying auto commit transactions. This happens by default. So by default, Galera will retry each such auto commit statement once in case it fails the first time. But you can increase the number of retries, and this will cause more statements to actually succeed eventually. So for example, if you have a multi-master workload where you experience 1% failure rate with the default auto commit value, you can try to increase it to 2 or 3, so meaning each failed transaction will be retried several more times, and you will see that the percentage of the transactions that ultimately succeed will increase, and the percentage of transactions that fail even after retrying will decrease. And then you can decide whether the number of failures in terms of percentage is acceptable for your application. But still, if you have housekeeping queries that perform a lot of updates within a single statement, retrying those may not always be useful, because if the first attempt to run such a long-running statement resulted in an error because it conflicted with another transaction, maybe the second and subsequent retries will also fail for the same reason. So in this case, you will need to split the work into smaller units, into several queries to get them to pass. Sync waiting is this ability of Galera to ensure that a particular transaction operates on the freshest possible data in the cluster. So by default, Galera will allow some slave lag to happen for performance reasons, because there are transactions that are always in flight in the system that are currently being replicated from one node to the others. So Galera will allow the nodes to fall by a few transactions behind other nodes if needed. But if you have a transaction that absolutely positively needs to operate on the freshest possible data, you can set this option. It is a session variable. You can set it within the transaction, and this will guarantee that this transaction will be blocked for just a small amount of time until Galera can be certain that it is operating on the latest data in the cluster. And it is important here to note that this sync waiting is property of the transaction that wants to read this fresh data and wants to make decisions based on freshest data, and not on the transaction that actually wrote the data in first place. The transaction that wrote the data in first place is always replicated the same way. So this option is about reading this data or making any operations or decisions based on it. And our final topic is how to deal with those multi-master conflicts, meaning those conflicts that happen when conflicting transactions are issued on different nodes at the same time. Those conflicts are unavoidable in a multi-master setup. So here are some guidelines about them. First of all, how to monitor for them on the Galera side. Galera provides two status counters for the purpose that you can read. One is recep local BF aborts, and the other is recep local cert failures. Those counters increase depending on when the conflict was detected and when the transaction was aborted. So in practice, what you need is to take the sum of those two counters, and this will give you the total number of transactions that failed because of multi-master conflict. And then based on these statistics, you can make a decision as to whether the failure rate is acceptable for your application. So on the application side, it is very helpful, as we mentioned previously, to enable logging of all the database errors that happen. If the application is a legacy one, for example, that is used to run against the standalone MySQL and is not used to getting any of those deadlock errors, any of those conflicts, then it may turn out that the application is not prepared to properly record the fact that the error occurred. Maybe the error will be sent to the actual web user in some cryptic message. Instead, what you want to have is the error printed in the log so that you can see it from your application, but most importantly, the log should give you some context information on the failing query, such as the function name where it happened or the source code and line numbers where the failure happened. The reason is that sometimes a select query will get a deadlock error. And what you're interested in is not so much as the select query, but which transaction it was originally part of. So with that in mind, you can set up your logging to give you this context information. Another important thing to log is an accurate timestamp so that you can synchronize the output from Galera about a particular conflict with the output from your application. So if you can synchronize the system time on both your application servers and the clusters, this will make matching errors between the logs much more convenient. Once you have that, you can enable this recep log conflicts variable, which means that Galera will print information about each transaction conflict, each multi-master conflict that it detects. And we will see an example of this output later. And you will see that the output is quite verbose. And therefore, please make sure that the logs will not overflow your disk space or anything like that. And finally, you can even enable the binary log, which will give you an information about the transaction that was not aborted because it succeeded in the conflict. Because for every transaction conflict, there is a winning transaction that is allowed to commit and a victim transaction that is aborted. The log output that we will see later is all about the transaction that was aborted. But if you enable the binary log, we have a blog post on our website that can show you how to extract information about the winning transaction as well, in case you need it to figure out what is going on. So here is the actual output from this option. This is just the output for a single conflict. You will see that it's quite verbose. And it is quite cryptic because it all comes from InnoDB. But still, let me try to decipher it for you. So first of all this information is about the transaction that was aborted. Then we have the time that the transaction was running before this conflict was detected. So here you will see that, for example, this was a long-running transaction, and that is one of the longer a transaction runs, the higher risk there is for some other transaction to be committed and to cause a conflict. So if you see long-running transactions being aborted like that, maybe the solution is to break them down into smaller pieces to work on. Then we will see the connection ID from MySQL, which you can use to maybe match this information with some other logs that you may have. We have the IP and the host name from where the client is connecting, and we have the username of the client. Then we have the query that was aborted with a deadlock error. But as we mentioned previously, what Galera is doing, it is aborting the transaction at the first convenient place. So the actual conflict, the actual writing of the same row on both machines may have happened from a statement within the same transaction that was executed previously. So here, sometimes you will see a select statement being reported. But this is simply because the deadlock error arrived while the select was being processed. But the underlying reason for the abort was some statement that was executed previously within the same transaction. And down here, there is information on exactly which row in which table is the row that is being contested. We have the schema name here. We have the table name, and we have the index name. This will be usually the primary key, where both transactions are trying to update the same primary key at the same time. And here we have the actual primary key in hexadecimal form. This is an unsigned integer, so once you convert it, you can get it as a decimal number, and this will be the ID of the record that those two transactions were fighting over. And in case it was a string value, then the output will decode the string value for you so that you don't have to parse this hex string up here. So once you have this information, what you can do to avoid such hot records? So it essentially means changing your application logic, if possible, to not update the same row or not update it as frequently as it's used to. So if you have a single record that is constantly being updated, for example, a single counter, you can convert it to a set of counters. So you can, if you start with a single row and a single counter, if you can convert it to a table with multiple rows, then all those updates will land on different rows within the same table, and hopefully they will not conflict with each other so much. Or you can even replace repeated updates with some sort of a logging table where instead of updating the table over and over again, you insert new records. Inserting new records is much less likely to conflict with anything. If it turns out that it is a long-running transaction that is never able to complete, for example, this transaction was active for 23 seconds here, you can consider splitting such transactions into smaller work units, which allow them to a higher chance of succeeding. For example, if you have some form of a garbage collection that takes your oldest 1 million rows from the database and attempts to delete them, maybe you can try to delete those records in portions of 1,000 records each, for example, and make sure that if a particular housekeeping transaction fails, then it will be retried later by some mechanism, and then hopefully it will succeed. And as a last resort, as mentioned previously, you can try sending all those conflicting write transactions to a single node, but note that you don't need to do anything so special about transactions that are not conflicting with anything. They can continue to be run against any node in the cluster. Okay, so this was the bulk of the presentation. And now please feel free to use the question or the chat box on your screen somewhere to the right, I think, to ask questions, and we will try to answer as many of them as possible. This recording will be made available on our website. You will also get a link in your email, and we will also make the slides available on the website as well. Okay, a few questions arrived. First, do you recommend to enable binary logs in all nodes? If there is an option called log slave updates, if this option is enabled, then all those binary logs will be identical on all the nodes. So you don't technically need to enable the binary logging on all the nodes. If you enable it on one, then that would be sufficient. Of course, it depends on what you intend to use the binary log for. If it's about debugging conflicts, then one copy would be enough. But if you also intend to use the binary log for backup purposes and things like that, maybe you would want to have more than one copy of it. Next question is, you say that we said that Galera will retry out to commit transactions if they fail once, and the question was what happens with if they continue to fail. If this recipe retry auto commit variable is set to, for example, 5, Galera will retry the transaction up to 5 times. Hopefully, it will succeed. If it is unable to get it through within those 5 times, then a deadlock error will be returned to the application. Galera treats each transaction as separate, so it will make a separate effort for each transaction. Next question is Galera replication logical or physical? It is a logical replication because it replicates logical updates made to the database. So it replicates instructions such as update row X to value Y. This is the MySQL row-based replication does the same thing. So there is no physical replication element involved here. Next question, would you recommend a commercial load balancer or max scale is sufficient? We as a company do not take any particular position on load balancing. We have heard that people have very good results with both max scale and HA proxy. So it seems that going with a commercial solution is not strictly required to get good performance out of Galera. Next question is whether do we recommend having read-only slaves in your load balancer if using multiple masters can result in a write conflict. Ideally, we would like to see applications that are multi-master ready and that work well on any node in a multi-master setup. But if the application cannot be made to do that, then of course you can always have read-only slaves in your Galera cluster. And those machines can be used to answer your select statements. Okay. I think those are all the questions that we have. So thank you very much. We have our website, galeracluster.com. We have other videos there, other demonstrations. We have blogs. We have our documentation there. And please give Galera a try if you're not doing it already. If you're using Galera in a single master mode, please give multi-master a try. We also have a fairly active discussion group on Google Groups that you can post about. And I now see last-minute questions that I will answer. What happens if one node crashes? Galera will automatically synchronize this node back to the cluster when it restarts. This is all handled internally in the product, and the node will be brought up to speed once it is restarted, and it will rejoin the cluster. This all happens automatically and inside the product. So there is no need to do any manual file copying or things like that. And yes, we're recording the webinar, so we will make the recording available. Thank you for your time, and have a good day. Goodbye.